it's given that this is a geometric series. If it wasn't, we could divide to see if there's a common ratio. Is the r value greater than 1 or less than 1?
Less than 1?
Here we have an r value that's less than 1. And so for a geometric series with an r value less than 1, we have a short form of the equation of the sum of the terms in the series to infinity is just the first term, a, divided by 1 minus the common ratio, r. This is just, that's it. That's the equation. It simplifies to this. 1 minus the common ratio. So what we need to do is find the common ratio of each series and multiply the sums to infinity. So we have a already for each series. How do we find r?
I guess you can divide them?
Yeah. Generally we find r equals tn plus 1 divided by tn, which is really just like the second term divided by the first term, for example. So doing that for the first series, 13 over 63 divided by 1 over 3 will give us 13 over 21. And doing that for the second series, we do negative 3 over 2 divided by 2 will give us negative 3 over 4. Sorry, this was supposed to be T1.
T1, yeah.
So that's what we did to find the common ratio. Just basically divide the first one from the second one. Now, we'll find m times n, which is the sum to infinity of the first times the sum to infinity of the second, and we'll substitute the values in for each one. The first term, a, of the series m is 1 over 3, and we're dividing by 1 minus the common ratio, which was 13 over 21, times the first term in series n, which is 2, divided by 1 minus its common ratio, which is negative 3 over 4. Now simplifying this, so this gives us 1 over 3 over 8 over 21 times 2 over
7 over 4.
7 over 4. Good. So what we do when we have fractions on the top and the bottom is we multiply by the reciprocal of the bottom fraction, so times 21 over 8 in the first parentheses, and 2 times the reciprocal of 7 over 4 is 4 over 7 in the second parentheses. Let me show you a little trick here. We could do the first one in 7 over 8 and the second one we could find, but when it's all multiplied together, we can actually do a bit of a shortcut. So on the right hand side, we see this is 2 times 4 is 8.
Yeah.
We have a denominator of 8 on the left side, so that would reduce to 1 and 1.
Oh, yeah.
So we'd have 8 in the numerator on the right and 8 in the denominator of the left. That would give us 1 over 1, and that would reduce. Similarly, you can see here we'd have 3 times 7 is 21 on the denominator. 21 in the numerator, we could reduce. 21 over 21 is 1 over 1.
Oh, so it's the entire thing is 1 then?
Yeah. So this values to 1. Everything in here is 1 times 1, which is just 1.
How does this geometric sequence formula work though? Because I'm trying to picture how it works.
Sure. Let's explore how the sum to infinity works for geometric series, so if you're interested, stick around. The sum of a geometric series is typically first value a times common ratio r to the power of the term number minus 1 over common ratio r minus 1. For a sum to infinity, what would we substitute for n? We'd substitute a very high number. Just picture that. This r will be a fraction. R is less than 1, so think of a fraction less than 1. What would happen with that to the power of infinity? Try it. Try some fraction on your calculator, like 1 over 10 to the power of a million, and you'll see that will approach 0. So if you understand that will approach 0, then we can write this as a times negative 1 over r minus 1, and this will equal negative a over r minus 1, and if we multiply the top and the bottom by negative 1, then the signs will be reversed. We'll get positive a over negative r plus 1, or 1 minus r. And so this is how we get the sum to infinity equation. So you can see it's important this only works when the magnitude of the common ratio is less than 1. It could be positive or negative, just the magnitude has to be less than 1.
If it's more than 1 though, does everything go to infinity then? Yeah, I guess. Yeah. Eventually.
Because it's like the series would be increasing, right? And it would just, the sum would go on. If r was positive and greater than 1, then the sum to infinity would approach positive infinity. Whereas if the r value is negative and less than 1, like negative 100, the sum would approach negative infinity.